Hey, good day, YouTubes. So, I'm going to attach an article below about LIGO. It's measuring gravity from other things that are happening out there in the universe we're still learning about. We've got a long ways to go. Holy cow, is it going to stop? So this LIGO detector. Now, LIGO is a location, the LIGO detector is a location in Washington State. It's on the Hanford Reservation area. Lots of technology going on in that area because nuclear's got the money for it. So, LIGO is detecting gravitational waves from outer space, but it is part of a large system. It is not just that detector sitting up there. It was by itself for a while, but now it has peers. It has other detectors doing the same thing, synchronized and focused to do it. But let's get back to this article's about LIGO. It's about noise discrimination, how engineers and scientists work together to figure out what's going on and make things better. Now, what this means to the real world, I don't know if it's ever going to feed billions of people, but some little incremental piece of that probably will help towards that goal. So LIGO collects data when it's turned on in the terabytes because the detector is so sensitive. And you don't want to decrease the detector's sensitivity. You have to be able to remove the noise. So we just got into signal to noise ratios and discrimination and all kinds of physics and equations that describe these things. And those equations match the realities we see after decades of study and tuning, because that's what we've done. So this noise that they're subtracting from that LIGO signal, that faint heartbeat of gravity from off in the distance, is a lot of work. It's parsing through those terabytes of data and subtracting and removing and finding the information in there that you can prove somehow, at least to your peers, maybe not to the general public. So in that signal discrimination, I learned that when a truck drives by the site, they have to subtract the truck noise from the signal. And it's subtraction, it's a math. It's sorting out a data set and selecting the good data. So the fact that they're throwing away more information is just interesting. I wonder who's looking at the other information they're throwing away. The picture I see is LIGO not only looks external, it looks internal because of the relationship of those different detectors across the globe. The physics, the timing, the precision we can now measure at. It's subtracting anything from Mother Earth it hears by its own nature, its own rules. The most sophisticated, sensitive detectors on the planet, and we've turned them outward. I don't believe that nobody's looking inward within the data. So, another piece of interest. It's like watching Parker Solar Probe information that comes in every few months in more terabytes of data. that somebody's looking at and making meaning of, and hopefully they let us know. But inside of this is this thing called interferometry. This is kind of one of the fundamentals of particle interactions, whether it's subatomic particles or the molecules, raindrops. Raindrops falling through the atmosphere run into interference. They evaporate, or they coalesce more rain, or they freeze and they become hail and coalesce more water and become huge chunks of hail. So, signal to noise ratios, just part of what we do. Thank you all.